Let's do some other examples of finding definite integrals using the fundamental theorem of calculus. This time, we're going to utilize some other functions, not just polynomials and sines and cosines. Let's integrate from 0 to 5, 1,800 e to the 0.12x power with respect to x. In order to do this problem, I have to remember how to take an antiderivative of e to a linear power. If you recall, in order to take an antiderivative of e to a linear power, I'm going to take e to that same power and then instead of having a coefficient of 1,800, my coefficient is going to be 1,800 divided by 0.12 or 0.12 if you want to state it like that. That is going to be evaluated from 0 to 5. The question asked me 0 to 5. By the way, 1,800 divided by 0.12, you can simply write that, or you can type that into your calculator if this bothers you, this fraction bothers you, as 1,800, again, I'm typing into my calculator right now, divided by 0.12, and that becomes 15,000 as the coefficient. So we're going to take 15,000 e to the 0.12x. I'm going to plug in 5 and I'm going to plug in 0. The top value I plug in first, e to the 0.12 times 5, or put that in parentheses. As you can see, as I'm typing this in, it's a pretty straightforward process, but be careful, especially in this second bracket. I will see a lot of people will plug in 0 into an exponent and then write that second bracket answer as 0. But that is not correct. The 0 is in the exponent. So this thing, e to the 0.12 times 0, that piece just becomes 1. 1 times 15,000 is 15,000. Now, in the other bracket, because e is an irrational number, you're going to end up with an answer that's irrational. I'm going to round it to a few decimal places. 27,331.78201 is what my calculator gave me. What I prefer to do is, because you get an irrational number here, I don't like to round until the very, very end. So what I tend to do on these ones where I know I'm going to get an irrational number, I plug the entire expression into my calculator at one time. Now the answer is probably going to be asked to be given as rounded to 2 decimal places. In this situation, it's 12,331.78 when I round to 2 decimal places. This one, as you can see, requires us to remember one of our basic integration rules, or In other words, our basic antiderivative rules. Let's do another example. Find the definite integral using the fundamental theorem of calculus of the integral here is from 4 to 9, and we're integrating square root of x with respect to x. Now, I am going to warn you that this is a scenario I see people mess up on a lot because they forget what step they're on. So here's what I mean by that. In order to take an antiderivative of the square root of x, what I really should do is I really should integrate from 4 to 9 x to the 1/2 power. I'm going to write 1/2 power as just the 0.5 power. Now that is a rewrite, and this is what I'm saying. A lot of times what people will do is they will mistakenly write the antiderivative as x to the 0.5 power. That's not what we're doing. X to the 0.5 power is the same thing as square root of x. So that's a rewrite step. And now I do the antiderivative step. The antiderivative step would say raise the exponent by 1. We get x to the 1.5 power. And then I would have had to have taken my coefficient and divided it by 1.5. Obviously, we're going from 4 up to 9 in the x values. If you wanted to rewrite this, 1 divided by 1.5 is actually 2/3. So if you prefer to rewrite that as 2/3, that's fine. I am simply going to plug it in as it stands. So 1 over 1.5 multiplied times 9 to the 1.5 power minus 1 over 1.5 multiplied times 4 to the 1.5 power. I'm going to type this into my calculator all in one step. That's pretty straightforward. 1 divided by 1.5 multiplied times 9 to the 1.5 power, and then subtract 1 divided by 1.5 times 4 to the 1.5 power. I did that all in a line, and I ended up with 12 2/3 as my answer, as my exact answer, and that is approximately 12.67 when I round to 2 decimal places. We could get that approximate symbol out, but I'll just leave it as an equal to symbol. Actually, that's kind of bugging me. So let me, there, hit the approximately equal to, just so that we know it's rounded. Again, what I like to do is I just like to do my rewrites on the same line, and then the next line go take my derivative, or antiderivative, excuse me. So I like to do rewrites on the same line, and then antiderivative on the next, and then plug in on the next, and then answer on the last. Again, if you think about what square root of x does, the fact that this came out as a nice mixed number of 12 2/3 should be a little bit astonishing. because of the nature of how the square root of x looks. It's this weird shaped thing. Here's what I'd like you to do. Push pause on the video and try these two problems on your own. Round your answers to 2 decimal places if you need. Again, push pause on the video and do these problems. On the next video, I will do them.